Hey everyone, my name is Dr. Galatia Strong. I'm a physical therapist who got 100% on my NPTE, and this led me to co-found SPT with me, which is an NPTE prep course. If you enjoy what you learned today, when you're studying for the NPTE, check out sptwithme.com. Now, for what you're actually here for, let's talk about Addison's disease. I am sure that you are all familiar with this image. It seems to be used all over different schools, which is great. Now, if you've been watching my videos, you're going to understand and remember that I hate memorizing pictures and slides. That is not the way to study, or at least that's not the way that I suggest to study. You have to make sense of what's going on. So we're going to make sense of the signs and symptoms of Addison's disease that you see on this slide. So one thing that you need to know is that Addison's disease is caused by adrenal insufficiency. So think about the adrenal gland that is on top of our kidneys. Now there's a lot that goes on with this gland, but understand that this gland is not working. Specifically, what I care for you to understand about that with respect to this slide is that the corticosteroids that are secreted by the adrenal gland, the hormones specifically of cortisol and aldosterone, these are not secreted enough. Cortisol is a hormone that partakes in our fight or flight mechanism. So we're talking about an inefficiency, which means there's not enough cortisol to maintain homeostasis. Now understand, we are not talking about, this person is normal, they just don't have the ability to turn from normal to get their fight or flight response. No, we're talking about this person doesn't have enough just to maintain a normal balance. We always have our sympathetic and parasympathetic systems on at low levels. This person doesn't even have enough to maintain the low level just to get us throughout our day. Now, the other hormone that you need to know with respect to this disease is aldosterone. Aldosterone is involved with the kidneys, and it's involved in helping to regulate blood pressure through excreting or retaining water, sodium, and potassium. The presence of aldosterone means that we want to keep sodium in the bloodstream and not pee it out. So water, as a result, is going to follow that concentration gradient so that we're going to be able to retain water, not excrete it in urine. So more aldosterone presence ultimately means you're going to have higher blood pressure. But in this case, with Addison's disease, we have low aldosterone. So we end up peeing out sodium, which in turn, water is going to follow, so we pee out more water. So this is going to make our blood plasma volume less because there's less liquid because we pee it out, so less blood pressure. So before we go into a little bit more detail, understand that there is a difference between Addison's disease and adrenal crisis. An adrenal crisis is a more acute version that is life-threatening. It's a life-threatening emergency. So if you see anyone who presents with signs and symptoms that appear in the box on the lower left, you should probably get this person some help. Now, adrenal insufficiency, aka Addison's disease, this can be managed as it's a longer-term condition. So as you can see on the slide, the highlighted ones, I am combining a lot of signs and symptoms together, which is the ones that we're going to talk about right now, because they're all related to each other, and this is how we get information to stick. We have to clump things. So we've talked about the role of cortisol and aldosterone in Addison's disease. So with respect to decreased serum sodium and increased serum potassium, again, this is a direct result of the decrease in the hormone aldosterone in this disease. Less aldosterone equals less sodium, more potassium in the bloodstream. So this should make sense. Again, water is going to follow the concentration gradient of sodium. So if we pee out more sodium, we're also going to pee out more water, meaning that the resulting amount of plasma, the resulting amount of blood that is circulating in our body is less than before. So we are dehydrated as a result of this. You're peeing out more water than normal. Now, look at postural hypotension. Think about the ability of our body and the circulatory system to be able to accommodate to postural changes, such as going from a supine position to sitting to standing, etc. In a normal person, it takes a decent amount of blood pressure and a decent amount of blood volume to be able to reach areas that are against gravity, such as our brain when we're changing positions. So, if we're standing up from lying down on the floor, our body is going to want to pull blood in the direction of gravity, because that's just how gravity works. Now think about if we don't have enough blood volume and our blood pressure isn't good, so that when we stand up, there's a lot less blood volume, a lot less blood pressure that is going to be able to help reach the superior or upstream locations of our body, such as our brain, right? Our body's going to take a lot longer and or at least try a lot harder to be able to pump the blood all the way up there. Vascular collapse. Well, arteries and veins are adapted to the amount of blood pressure that they're subjected to. If there's barely any fluid within the tube of your artery, your tube or the artery walls are not going to stay up as a plump tube. It's going to collapse because the lack of blood volume within it just isn't enough to press against the walls of the artery to make it plump. So as a result, it's going to collapse. Renal shutdown. Again, we've talked about how blood volume is decreased. This happens not only in certain areas of the body, it's throughout the entire body. When there's a reduction in blood volume, when blood makes its way to the kidneys, there is not as much as there normally is. So as a result, there is less renal perfusion. There's less glomerular filtration rate. Now, think about this in general. Anytime that an organ gets a reduced amount of blood flow or just isn't given enough to do its job, it's going to be damaged. If you think about the brain, we don't get enough oxygen, blood flow, to the brain. There's going to be brain damage. So think about something like a stroke. So the same idea goes with the kidneys. You're going to get kidney damage if there isn't enough blood flow to it. Next, we have fatigue. So think about a few reasons that can lead up to this. So number one, think about, again, blood volume. What is blood made of? Well, one of the components is oxygen. If we don't have a good blood pressure that allows our already lacking blood volume to be sent and circulated throughout the body, then oxygen isn't going to be circulated either. Oxygen is what gives us energy, right? So if we don't have this ability to distribute oxygen to areas that need oxygen, we're going to have fatigue. Now, when you have fatigue, are you going to want to exercise? No. So if you don't exercise, are you going to get strong? No, you're going to go into the opposite direction. You're going to get weakness, which is another sign and symptom. Furthermore, again, with aldosterone. The lack of aldosterone leads to the lack of sodium within our blood. Sodium also directly relates to the ability of a muscle to contract. So think about the process and steps of excitation and contraction at the level of the neuromuscular junction. Fun. But you know, the idea of getting a sarcomere to perform the sliding filament theory with myosin and actin, you have to have sodium to initiate the process. Well, if we don't have sodium due to peeing it all out from a lack of aldosterone, this is ultimately leading to muscle weakness. So understand that it's not that all of a sudden our muscles start to get weak. It's from the physiology behind it that is not allowing us to really even start that muscle contraction. Now, considering that and its role in weight loss, you have no energy, you're weak, you're feeling nauseous, you have abdominal pain, you're throwing up, you're gonna lose weight over time. Now, there's some things I just mentioned, such as nausea, abdominal pain, throwing up. I know we haven't talked about this yet. These are with respect to GI disturbances that you also see on the screen. It's just not highlighted. However, that is coming up. So, with just two pieces of information with respect to cortisol levels and aldosterone levels, we were able to explain the signs and symptoms behind a majority of what are present on this slide about Addison's disease. Clump things together, hopefully it makes sense. But of course there still are a few more, so let's go through those. So as mentioned, GI disturbances, so let's get right into that one. So think about nausea, vomiting, and abdominal pain, just things that I've already mentioned. With this, I want you to think about the balance between our sympathetic and parasympathetic system. As mentioned before, you have to have homeostasis. So between the two, we actually have a subtle activation between both just on a normal basis. So me just sitting right now, talking to you, and you watching this video, they're on, just at very small levels. One might be higher than the other. So when one is working more than the other or less than the other, this causes an imbalance. Whenever there is an imbalance within the GI system, the way that it's going to tell us is through referral pain and through the opposite of what it normally does. So you think about the stomach. Its job is to keep food in and digest or emulsify. But if there's an imbalance, what it's going to do is tell you by giving you information of the opposite job, which is you not digesting and keeping it down, you're going to throw it up. And so nausea, vomiting, and referral pain are GI disturbances that you'll see with Addison's disease. Hypoglycemia. Think about the role of glucose in fight or flight. If you're running away from a bear, your body's going to want to break down stored energy into glucose so that you can use it to fuel yourself to run away from this bear. In the case of Addison's disease, remember that our ability to have fight or flight, even at our baseline level, me just sitting down talking right now, our level to do this is reduced. So even at rest, this person has hypoglycemia. Bronze pigmentation of the skin. So I saved this one and the next one for last because their reasonings for its occurrence is a lot different than the rest. So for this one, essentially, because the body secretes such a low level of cortisol, it's going to actually trigger an increase in the release of a different hormone called adrenocorticotropic hormone. Why the body does this is to attempt to balance itself out. Our body has a lot of different ways to try to get homeostasis, even if it can't get there fully. Now, what this hormone does, adrenocorticotropic hormone, is that it leads to a high level of melanin, which is that chemical that provides our skin its color. And the high level of melanin means that you're going to have more of a color in your skin, a darker color. So this darker color is considered hyperpigmentation. If it weren't for this disease and for this increase in this hormone, presence of this hormone, the person would not have this pigmentation. So this results in a bronze look. Changes in distribution of body hair. So again, the reasoning for this is a little bit different than what we've been talking about, so save it for last. Hopefully not to confuse you. But understand that adrenal insufficiency, aka Addison's disease, is caused by damage to the adrenal gland, as I have mentioned before. Cortisol and aldosterone are not the only things that are affected. Of course, I spent, again, a lot of time on those because they do help to explain a lot about what we see with respect to the signs and symptoms of this disease. But just understand that's not all. So in the case of distribution of body hair, we need to consider that with Addison's disease, the entire adrenal gland is affected. So another thing that the adrenal gland does is secrete androgens. Androgens have to do with sex hormones, and sex hormones have to do with testosterone, which result in deciding the presence or absence of hair growth in certain areas. So what's interesting to know is that actually androgens in males are not so much secreted in the adrenal gland, but instead the testes. So Addison's disease in males does not really have too much of an effect on body hair distributions. However, with women, because there are no testes, and so these sex hormones are mostly coming from the adrenal gland, there is a change. So there might be some hair loss in some regions, and there might be some hair growth in other regions for females. Hopefully this clears some things up about Addison's disease. If you enjoy this content, check out SPT with me when you're studying for the NPTE. Well, since I talked about Addison's disease, I should probably do one on Cushing's disease, huh? All right, idea for next time. Check out this reference if you want more information.